Thank you all for coming today, and if you'll sit down, I'll get started. All right. But I just want to thank everyone for coming, and I'd like to just say I'm John Scheik from Advanced Systems Group, and I'd like to introduce our local chair, which is Keith Graham. Thank you.
Hi folks, now the microphone doesn't work, it's only for streaming purposes, so don't worry about it. But you should, with the Maya system, be able to hear me perfectly well, even as far as the back row. What? Okay. So anyway, welcome along. This is actually the second local section meeting in June, because we had the ET conference at the beginning of the month, which was very well attended, for those of you who were able to come to that. But anyway, this is our June meeting. We probably won't have July or August because of the summer break, but stay tuned for September at Pixar. So, ooh, yeah, okay. So anyway, thanks very much to NetApp for hosting us tonight, and we've got some. You've been on a little bit of a tour. I think there's some more scheduled for after the presentation tonight. So a number of things to talk about. So we've got Jason going to talk about NetApp. We've got, I think, Dave, you're going to say something as well. And of course, we have Jessica here from Maya, who's going to talk to us about the Maya system. So over to you.
Hi, I'm Jessica. I'm one of the acoustic engineers at Meyer Sound as part of the Constellation team, and I was part of this installation. How many of you are familiar with the Constellation system? Oh, okay. And how many of you have heard a demo before? Okay, good. So there's still quite a few of you who have never heard this. So Constellation is actually a variable acoustic system. So you can control the acoustics of a space in a single space and use it for multiple uses. This is great for corporate theaters such as this, or multi-purpose spaces, classrooms, lecture halls, performance spaces, you name it. VoiceLift is a functionality of the Constellation system, which is actually the Constellation system that is in here. VoiceLift, this system has two different presets. It has a presentation preset, as well as a Q&A mode, question and answer preset. So right now we're in the Q&A mode, which is all of you guys should be able to hear each other if you wanted to communicate to each other across the room without using a microphone. I have a microphone, but this is only for broadcast purposes, so actually you're not hearing me through the PA at all. And if we were to turn the Constellation system off, which they're going to do in this control room, you'll notice that you won't be able to hear me as clearly, and you won't be able to hear each other. So I'm going to have them turn it off, and hopefully, yes, and I heard it. So now I'm up here, and hopefully you guys have heard a noticeable difference. And I would probably, yep. I would probably have to shout a lot louder and be a little bit more exhausted for you guys to hear me over that. Yeah, so I'm going to have them turn it back on now. And so there's also a presentation mode, which will just be me up here, so you guys won't, the noise won't be picked up from you guys, and it won't be disturbing to the rest of the audience. But yeah, so that's basically the system in here. Whoop. And I think at some point in there they turned on the fun demo setting, which is reverb. So another one of the awesome components of this system is the reverberation settings, which we use a lot for musical settings. They're not really appropriate for VoiceLift because you're adding reverb to the room and actually decreasing intelligibility. But I'll have them turn that on just for fun because it's a fun demo. So let's see. Yeah, okay. So then I'm going to hold this mic here and hopefully, actually, I'm going to sit it down because I don't want to clap right into it. But and then have them turn it off. that's just a quick demo. I'm going to bring the mic back. And they probably didn't hear that on the broadcast, unfortunately, because you can't hear the room. But if you guys have any questions for me, yeah, sure. They are actually above you. So they're kind of small. And these ones are dark, but there's some microphones here above me. 44. Yeah, so there's 44 microphones in this room and 83 loudspeakers. So the loudspeakers are actually hidden in most of this room behind all the fabric, but they're everywhere. They're all around you and overhead, and the microphones as well. I believe they're all discrete outputs. So there's 83 channels. And that does not include the left, center, right screen channels, but the cinema is actually shared with Constellation. So the 7.1, I believe, is the cinema system in here. And they're sharing the loudspeakers that are behind those fabric panels. Yeah, so unfortunately here I don't have connectivity to the system, but you could just, it's a web page, so you could just have an iPad that I would have here if there was Wi-Fi that I could connect to, and it's just a push of a button. So we program all the presets. The Constellation team will come in and do a tuning, and we'll provide the presets that the client or end user would want of variable reverberation times or different performance types or classroom settings, room configurations. We do all of that in advance, once, like right after the room is complete, and then it's just the push of a button. So unfortunately, I don't have the buttons in front of me, but they do, so that's why they're controlling it. Yeah. Any other questions? Yeah.
I just think we should do a special thank you to you, to Meyer Sound, as well as to Advanced Systems Group for
Definitely.
sponsoring the beverages and the food and everything.
Oh yeah, definitely. Thank you. Great. All right, and then who am I passing this on to? Dave. Oh, I get to pass it on to you. Oh, you have your own microphone. Okay, perfect.
I don't see. This must be the cues. So we're going to bring up the presentation, guys. I assume they can hear me in there. Oh, no, here. That'll get you in there. Ooh, look at that. All right. For those of you who don't know me, I'm Dave Van Hoy. I'm the president of Advanced Systems Group. I'm actually trying to look in the crowd and see if there's anybody I don't know. Tonight, what John and Keith asked me to talk about is storage in an overall sense. So tonight I'm not going to talk about particular brands of storage or make any particular pitches. One of the things that we've ended up doing across the history of the company is building a large practice in high-speed storage or large storage pools for media. Media tends to be kind of on the big side. And we get a lot of questions about how do I look at a system? How do I go to a vendor and buy a system? What kinds of things do I need for, how do I specify it? And so I actually have to go through kind of the same learning process with our own staff. As salespeople come in, they may or may not have dealt with this before. Sometimes we have people who are long experienced in video workflows, but not necessarily in storage. And I started putting together chunks of slide decks that I mostly stole from other people, because that's how I got trained. And as anybody who's ever worked with me knows, I'm a terrible graphics person, so I pretty much have to steal everything. So tonight, that's what we're going to do. We're going to take a walk through different types of storage, starting at the very building blocks at the bottom. And some of you know this, some of you don't. Hopefully I get to some parts that will at least be a little interesting. At the end of it, my goal is that you'd be qualified to work at the company as an entry-level salesperson. So, all right, so I assume we're using the DSAM tonight, guys? Or not? Here we go. All right, so this is the kind of stuff we're going to cover tonight. And as it's funny, I've designed so many of these, I am not used to using the monitors at the front of the stage. So I will be a good boy and behave like a presenter. as I see somebody over there glaring at me. All right, so tonight we're going to talk about disk drives, what they are, some different kinds of disk drives. We're going to talk about how they interface to get out of the data, different kinds of ways of getting to the computers themselves, what kinds of interfaces, because there's a plethora, a little bit about data protection in kind of a survey mode. We're going to talk about software-defined storage, a whole new term that has popped up that seems to be increasingly popular as a topic. And then we're going to talk a bit about shared storage and how you can deal with shared storage in your facility. And there's, again, many, many different ways to do this. I will say up front, the beginnings of this particular presentation literally go back to about 2001, when we were just beginning to do some of the early shared storage. It's amazing what's changed, and it's amazing what hasn't. That many of the actual issues about how a system goes together are exactly the same now as they were 20 years ago. All right, so, ooh, that graphic worked well. I love when you import one of these. So one of the first questions we get when we start talking about storage and professional video is, how come a drive that I buy to run my Premiere system or my Avid system or whatever it is costs more than the $49 I would pay for an 87 terabyte drive at Fry's? And you say, well, it's a better drive. Well, what do you mean by a better drive? And it's really about a little bit about performance. It's a lot about how long the thing is going to last. And that when you buy a drive for home, they figure you're going to use it X number of times, and you're going to store your pictures on it, and if you're smart, you're going to back it up, or maybe put it in the cloud, or whatever it is as backup. But at the end of the day, if you lose that drive, nobody's going to die, nobody's car is going to veer off the road, nobody's bank account is going to get lost. Versus when you're in an enterprise situation, this is for real important data. It's your CAT scan. It's the video that you cut as a professional and get paid for. It's the masters for a film, whatever it is. So they're actually designed to a very different specification. You could think of it almost as the difference between a tire for your car that you buy at Big O and the tire that goes on an Indy car. A big difference about when it spins at 5,400 RPM or 7,200 RPM versus 10,000 RPM. And that goes to performance, goes to how long is this thing going to last. Today, there's two intrinsic interfaces that go on most physical drives. And yes, we will talk about SSDs a little bit. Everybody always wants to know. You've got desktop storage, which is generally based on a SATA interface. And then you've got enterprise storage, which is generally based on either SAS and now going away fiber channel. Interestingly enough, we'll go through a chart here, and you'll probably see an acronym you have not heard in a very long time, which is SCSI. Because what is SAS as an acronym? Serial Attached SCSI. The protocol that goes back to, literally the 1980s is still the underlying way the data moves on and off virtually every disk today. And most SSDs. We have exactly 2 slides on that if people are still awake. So this is a little bit old now. I updated it a bit, but wanted to give people sort of a sense of what different kinds of interfaces look like and what do they mean? What is USB? What's its speed versus FireWire, for those of you who were around in those days. eSATA, SATA, just for fun, SCSI in its last form of what it was when it was called that. Fiber channel, which, by the way, uses SCSI protocol. iSCSI, which, by the way, uses SCSI protocol, just in case anybody felt you needed to invent something new. Ethernet in all of its various forms today, and Thunderbolt, which is going through various forms. Right now it's 20 gigabits a second each way. So when you go to design a system today, it's really, there's a few basic 4 questions that you have to kind of think about as you are trying to look at talking to vendors, reading 1,000 web pages that don't make any sense, that completely conflict with each other and call each other liars. No vendors ever do that. What is the throughput of my video content? What is it that needs to play? If I am sitting at a single machine and I have a copy of Premiere running and I've got HD content, what codec am I running? Am I running ProRes at 220 megabits a second? What are my typical number of streams that I play when I'm editing? 2, 3, 4, or in my case 1. And this becomes the basis for how you look at your overall need. Then, how many terabytes do I have to scale to? Which is, how much time am I going to store at that resolution, at that bit rate? And then, do I need to share it with others? In real time, not in real time? And then how much money am I willing to spend at it? At the end of the day, whether I'm working with Jeff over here and I'm designing a 10 petabyte system for a big Fortune 100 client, or whether we're doing a small direct attach piece of storage for somebody who's editing their dream doc in their living room, these 4 questions are exactly the same every single time. So this slide is probably my favorite because this slide really is from 2001. And it hasn't changed in all that time. In the old days, when we started and we had basic computer editing, every room had a computer. Every room had its own storage attached to the computer. Mr. Weissman is nodding over here because we certainly lived that one. And if you wanted to move something from room to room, you had to copy it to another piece of removable media, or you had to pick up the array and move it. Or if you were really insane, you did something like a SCSI patch bay, or who knows what kind of crazy things we did. But it wasn't very convenient in the sense of if I needed to share my media with somebody else, or if I was going away and coming back and somebody else was going to use the room in the meantime, that means my stuff was sitting there while they were there. Or when I came back, if I needed to go to a different edit bay because the one I was in was now booked with somebody else, it was kind of a problem. So the first systems that kind of solved this were SANs. So let's see. Mr. Chen, over in the corner over there, what does SAN stand for? Storage area. Exactly. We'll talk in a little bit about the difference between what is a storage area network versus what we think of as a general network. But the basic premise of what we were trying to solve was making it so we could have a pool of storage that then multiple users could use in real time. That was the big difference, in real time. Some of the early players in this were products like FiberJet and Mercury Computing and Tivoli, which eventually was bought by some company named Avid, might have become Unity. And, but the basic thing was that you needed to have pooled performance, and you wanted to have it in a single place so that everybody could use it. The fundamental problem with this for early generations of shared storage was it was a pool, you all connected to it, and how do you keep from writing all over each other's stuff? And more importantly, how did you do any kind of protection from the other user? And the answer is you couldn't. Once you put it on there, kind of everybody saw it. The file systems were not sophisticated. They basically emulated a local attached disk. And about the only thing you could do was virtualize the volumes and not allow the other user to mount any of the other virtualized volumes. So then came the idea of file level sharing, which was a big change. And for our company, the way we learned about that really was this product that Apple developed early on called XSAN. And little did we know what that was going to become to all of us, but certainly to our company. And it was based on a file system that allowed you to now create access based on files instead of chunks of disk. This set the expectation for what we consider to be modern shared storage today, whether you're doing it on a NAS, whether you're doing it on a SAN, whether you're doing it in the cloud. This is the basic underlying problem that we're solving, is how do we have multiple reads and writers, how do we control access, and what tools do we use to do that? And in the SAN world, we call that a metadata controller. That was long before anybody had thought of the idea that metadata would be a word you'd use in things like media asset management systems or anything else you do to describe it. But the metadata was where on the disk did I put it? And Apple did a great job of making this technology affordable and ubiquitous and literally changed our industry. It was the first time that almost any facility could buy shared storage that would really allow you to edit in real time. And they did a great job. Now, of course, what we didn't know early on was that they actually licensed all that technology from the company that we now know today as Quantum. And that's why today, every copy of Mac OS comes with an XAN client in it still and plugs directly onto a Quantum shared storage system without having to buy any other software or interfaces. But it set a mark for everybody as to what the expectation was going to be around performance, around the ability to share, and quite frankly, changing the cost factor. So there's today really two different ways about going about sharing your data. One is with a SAN and one is with a NAS. Mr. Chen, what does NAS stand for? Ah, a very different concept. Network attached storage as opposed to a storage area network. So in a storage area network, every client sees the storage equally and directly. In a NAS, you have storage behind a file system served by effectively a server. Could be a NAS head, you could call it whatever you want. But the file system is managed and running on that computer. A very big difference in how you go about it. So if you think back 10 years ago, where computers were not any faster than they are today, right? So 10 years ago, if you wanted to do real-time video, you were probably going to have to build a SAN because there were no computers that could go in the middle to pick the data up off the disk and serve it out onto any kind of network topology fast enough to make a copy of Final Cut Happy or Premiere or even Avid. That's changed across the last few years. And in the corporate world, or in almost any normal work world, NAS storage has been the norm for a very long time. Everybody's gotten used to having shared email boxes and shared drives and shared, whether it's cloud or whether it's local, it's really a NAS. Over the last very few years, now all of a sudden computers are fast enough to be able to pick up disk, pick up blocks, move them across their bus and out onto standard Ethernet, mostly protocols, in real time so you can have performance. So today you have choices about how you go about this depending upon your requirements. Back to those same 4 questions at the very beginning. Oh, actually, let me go back and see if I can go back one. Is it going to let me do that? Nope. Okay. One of the things when you get into this is you're going to start looking at protocols and how things move from place to place. A protocol is the language that your devices speak to see the storage. And you want to get to the mode where you're separating that from the physical transport layer, which is how did this thing connect? Because they're not tied together. People think they are at first because you kind of see them bundled together. But in truth, that's not really what happens. So in a NAS, generally you've got Ethernet delivery to the clients. You might have an array of protocols. Could be NFS, could be SMB, could be a proprietary one like Quantum's DLC. but the basic underlying transport is an IP-based packet. NASs in general do not require client software that is not part of the OS. There's a few exceptions, but in general, NAS will run on standard protocols. Today, this one needs to be updated some more, but mostly NASs were used up until a few years ago for non-real-time things, sound effects libraries, lower bit rate, backups, and they were not very dependent upon network performance. SANs, the concept was, there's nothing really between the user workstation and the storage itself. The SAN as such, when you're buying a StorNext or whatever product you're buying, is a traffic cop. All it's doing is making sure that you don't write to the same place on the disk at the same time and telling your machine where on the disk you left it. It's a big difference from I've got to travel through the computer to get to my computer versus the computer that's over there as a metadata controller is just telling my computer where the data is on the disk. And that's why SANs tend to be faster and tend to be more guaranteed performance. So today, the two big ways we connect our end user devices to the shared storage are generally over fiber channel or over Ethernet. And up until really only about 18 months ago, if you wanted the highest performance, if you were looking at doing 4K, reasonably uncompressed video, you had pretty much no choice. You were going to do fiber channel. Fiber channel is highly determinate. It has basically guaranteed packet delivery, which is a nice network term for saying there's not much in the way. And the great thing about it for video editing is in network design, one of the things you go for is you want things to be deterministic. You want to know when I ask for a block of data, how long is it going to take to get here? And I mean, if you think about it, that's not such a hard concept about what happens if it doesn't do that. If I'm editing along at 30 frames per second, or today, more often than not, 60 frames per second, and I ask for the next frame of video from the storage, and I'm Premiere, and I don't get that frame of storage, that frame of video, I might be unhappy. If I miss a couple of frames, I might get really unhappy. And so that becomes the underlying job of the storage system, is to deliver the data in a timely fashion. And if you look at it today, even now, the fastest storage you can buy, Jason was talking earlier about solid state storage a little bit. The underlying transport for all of those most fast interfaces is still fiber channel. It is guaranteed performance in a certain amount of time. In Ethernet, the nice thing about Ethernet is, how many of you own a computer? How many of you own a computer with an Ethernet interface on it? Yeah. If you have one that doesn't, I'll invite you back to the 70s. Because your Wi-Fi is Ethernet. Everything is Ethernet. So what Ethernet is ubiquitous, which makes it inexpensive to deploy in comparison. Fiber channel is a specialized technology. Ethernet is a very ubiquitous technology. And even if you go to the broadcast side of the world, where we're beginning to talk about getting rid of deterministic pieces of wire like SDI, which stands for Serial Digital Interface, sounds strangely computer-like. There's a movement to go to Ethernet-based transport there in the form of SMPTE standards like 2021. And what allows us to do that today is the fact that these devices are widely deployed, making them less expensive to try and meet a certain performance goal. So the problem with Ethernet is that it's a packetized, multi-directional protocol, which means that it has to deal with the fact that multiple things might try to talk to the same thing at the same time. Might happen in your switch, might happen at the client seat, but it's going to happen somewhere. You're transmitting a bunch of data down the wire that may or may not be related to each other. So if you think about that, you'd say, why would you want to use that in a storage system? Well, or how could you use that in a storage system, knowing that now I don't have guaranteed performance as to when this thing is going to get there. And it's the old theory of, if I need to deliver X number of gallons of water to a certain place, I need a pipe that's this big. But if I want to use a smaller pipe, then I might use more pressure. So what you do is you over-provision. And that allows you to use this much more ubiquitous technology at a higher speed. So this drawing actually should be near and dear to some people's hearts. It looks a lot like your systems that you've run over the years. This is what a typically large mixed-use SAN and NAS looks like now. So what we have is storage arrays, a fiber channel backbone, and metadata controllers that control, just for fun, I left the old Xserves in here to see how many people would recognize them. And then we have client seats that are connected over fiber channel, but we also have clients that are connected over Ethernet. That's another big change as you think about how you are deploying and what you're going to buy today. The rules aren't hard and fast anymore. It used to be I bought a SAN, I was going to deploy it over fiber channel, that was that. Or I was going to buy a NAS, I'm going to deploy it over Ethernet, that was that. Today's systems are flexible enough to allow different kinds of attach for different kinds of users within a single system. Sometimes they get really complicated. And thank you to my friends at Yahoo who allow me to use this slide. This shows how you can have multiple sets of storage with multiple different kinds of attachments in multiple different physical locations attached through both virtual private networks and direct attached. So the possibilities of how you get from here to there are remarkably high today. This particular system has a combination of SAN, NAS, cloud, and WAN, all to facilitate their workflows between sites. All right. Any questions? Been very quiet. How am I doing for time, John? About 5 more minutes? Okay. So today, beyond transport, beyond file system, we have some new storage technologies. We all kind of know about this thing down in the bottom, in case anybody guessed. HDD stands for hard disk drive. And they've been around a long time. But today you hear a lot about solid state storage. And we get a lot of questions about where does that fit in my ecosystem. If you buy a new MacBook Pro, you can't buy it with anything but solid state storage in it, or an iPhone, or a ThinkPad, or a Dell. Just for fun, I actually asked our Dell rep this morning if there is actually a laptop that they sell today that has a hard drive in it, and the answer is no. So it tells you how ubiquitous solid state storage has become. Why would we care about solid state storage in the kind of shared storage environment we're talking about tonight? What would that gain us? That's right. So in shared storage, your performance is, if it's done right, the aggregate of all of the individual storage devices within that system. And there's a lot of things that go with that. How the data protection runs, what kind of data protection, is it software defined, is it hardware RAID? But at the very bottom of the food chain up is the storage device itself. So what is ubiquitous today is SSD, which solid state disk, that was hard to figure. The idea here is I've got a bunch of RAM, I put it in a case, I attach the same user interface, or the same electrical interface and protocol interface to it that was a hard drive, and now I have a faster thing that I attach to exactly the same technology I had before. Useful up to a point, because spinning disk has limitations. You've got the rotational speed and how fast I can read the bits off of it, but maybe not the fastest access that might be possible if I could talk to that underlying silicon directly. So today, in a sort of a ubiquitous way, we've got hard drives, we've got SSD, and we've got DRAM, which is generally what's attached to the CPU of your device. Okay, Ed, what's DRAM stand for? There you go. See, it helps to ask the guy with the engineering degree in the room. I'm just making sure you're awake. It's much easier to pick on one person than a whole group. So all right. So now we have what came along next was this hybrid flash disk stuff, and so that was like Fusion I/O, and we saw that in some of the Macs for a little while, and that was. It was still too expensive to use all RAM, to have a large amount of storage, but you could gain some performance by putting some cache in front of it effectively. And then where we are today, which is where we have pretty ubiquitous SSDs. And this is where we're going to get to some interesting questions about solid state storage versus hard disks. So as with everything, you can have, how's that go in construction? You can have speed, quality, or price, but not all three. Pick two of the three. It's kind of the same in storage. So today, we have SSD-based consumer-level devices. And that's what's in your laptop. It's what's in your iWatch. It's all of these kinds of devices. It can give you a lot of space, not very expensive, but it has some interesting compromises. Notice that this is capability versus cost. It's an interesting graph that I actually got from some NetApp folks. Then you have this concept of persistent memory, which this is where the concept, where you'll hear a lot about things like NVMe, a non-volatile memory express. And then you have, of course, hybrids, because when one technology is expensive and the other one will do part of your job, you mix them together. So it's almost the equivalent of those early hard drives with SSD in front of them as cache. This is pretty good because it gives you kind of a layout of what do these different kinds of technologies cost today in an overall sense. Straight up disk being ubiquitous, inexpensive for its size. Then you've got the hybrids, more SSD, and then at the end you've got DRAM, which is the most expensive RAM per megabyte. So just like in disk, just like in everything else, it's a matter of cost versus performance for your application. If you're rendering very large frames at high bit depth, you're doing HDR, 4K, you probably care about how fast you can get stuff on and off the storage in a big way. If I'm editing, XDCAM 100 native, probably not as big a problem. So how many of you have heard of NVMe, or at least heard the acronym? Yeah, I'm surprised actually. There's a few people besides the people who work for us. The NVMe is the newest form of storage today. And what it's all about is the fastest, highest performance between the CPU in your machine and the storage on itself. And today, NVMe is talked about a lot. It is beginning to be more ubiquitous. I think Jason will probably talk about it a little. Are you talking about it in your slides? I didn't look that close. There we go. Exactly. And they are different. Today, the most common way to interface to this kind of high performance storage is mostly fiber channel still, because it is fast and it deploys a protocol that allows you to access the RAM, effectively access the solid state RAM directly, as opposed to going through one more layer. So you have SSDs, you have SSDs attached versus via NVMe. And what this will show you is what I was starting to talk about, which is latency. So that early on I was talking about kind of how fast it has to go. Fast is a combination of how big the streams are and what is the time to get it back. So if I'm running a higher frame rate, I need much lower latency. If I'm running multiple streams, I need much lower latency. So this is starting in the left, hard drives are about 10 milliseconds. A basic serial attached SCSI SSD is about 80 microseconds, turning down to about 5, depending upon a few things. Then we have SSDs that are speaking NVMe protocol instead, and they're down in that 5 microsecond range at the better part of the performance. Then we have NVMe that's sitting inside your machine, so it doesn't have to go across any kind of other external bus. And then we have NVMe that is traveling over a SAN, which is the first time we've ever had the ability to have storage that can be in a shared pool that can talk to your machine almost as fast as if it was in the machine itself. So it's going to be a sea change in terms of how shared storage works and how these kinds of designs are going to work as we go forward. I will publish out for everybody, in case you can't see it, but this is the basic definition of what is NVMe, which is non-volatile memory express, is what it stands for, and the OF is over fiber. So, yeah. I'm sorry? Or fabrics. Yes, well, most fabrics are fiber today. So, and this is what it typically looks like if you deploy it today. And in fact, today, you can actually take NVMe and deploy it over many different kinds of shared storage. You can do it with SANs like StorNext. You can do it with file systems like Lustre. And basically what you're doing is you're building up a storage CPU. You're putting a lot of storage in the CPU, and then that becomes your storage device. And this is where you'll hear a lot about the concept of software-defined storage. So that's probably the last thing we should talk about quickly, because it's so topical, comes up all the time. Data protection for the last many years has been achieved through various forms of hardware-based, what are called RAID controllers. And they'll run all kinds of different protocols, different levels of RAID. Okay, Mr. Weissman, what's RAID stand for? Independent disks. Yes. Yeah. And no. Yeah. But today that could be done. That's often done in software. File systems are now defined in software as opposed to physical boxes. And so now we are heading towards the concept of what is a storage device? And this is a great illustration of that, where you've got a CPU stuffed with storage. What's the difference between that and what we think of as a RAID or a NAS? Interesting things as we go forward. And this I stole from, I think, Brocade, actually. Wanted to give everybody sort of a sense of how fast these interfaces are today. The vast majority of the fiber channel that's deployed in the world today is 8 gigabit. And that's been doing everything up to 4K for quite a while now. 16 is becoming it's pretty ubiquitous. Everything new is that. And we're just about to deploy 32 gig. And this gives a very graphical illustration of the amount of time to move the same size piece of data across these interfaces. So when you're thinking about what you want to pay in your system and what's important to you and how you need to future-proof, these are the kinds of things you want to look at. And I think with that, we can call it. There we go. Thank you.
Good evening, and thank you for coming. I'm Jason Danielson with NetApp. I've been with NetApp for about 8 years. I spent most of that time here managing our media and entertainment industry efforts. Is there a remote control? Oh, the green button, the big one. Makes it easy, yeah. We could spend more time on NVMe and NVMe over Fabric, but from my perspective, while we have probably shipped more NVMe over Fabric than any other manufacturer outside of perhaps IBM, who's been shipping NVMe over InfiniBand for a couple of years, it's going into banks primarily. It's going into database operations where that lower latency down into the tens of microseconds makes a big difference as to how fast Oracle databases run, basically speaking. Video doesn't need NVMe over Fabric of any nature today, over Fiber Channel or Rocky V2 over Converged Ethernet or InfiniBand. And we're shipping an awful lot of NVMe drives into those same banks as well, which helps with their latency, but that performance, which the data center folks care about, that level of latency is so low even today in what we're shipping with disk drives and SSDs running SCSI, that we don't have issues at the highest resolutions. Although we do have customers that hear about SSD, hear about NVMe, they want the latest technology, they think they absolutely need it. I've got a customer right now that's editing with Adobe at 4K and would like to have that performance. They don't need it. We could sell them something more cost effective that would solve their problem, but we're a storage manufacturer and we'd love to get more money from the customer. The customer wants the latest technology. It's kind of that evil, vicious cycle of, okay, we'll give you the latest technology, even though you don't need it, you'll pay more for it, we're happy with that part. You want the latest technology, great, we'll go do that. But I'm going to back off of that here for a minute and go back in time here for a minute. I thought, I'm so excited to have a bunch of video and audio engineers here in the room instead of a bunch of data center CIOs to talk to, that I thought I would bore you for about a minute and a half with my brief history of recording video on disk, because I realize that this is a central core of my career. 40 years ago, when I was first getting started in video, I was teaching a video workshop up in Marin County. One of the workshops I taught, there was an engineer from HP who came up from the valley to Marin County and took this workshop because he wanted to learn how video worked. Back then, I think we were working with black and white, half-inch reel-to-reel tape. So it was a 270i. Well, it was analog, so what the heck? I mean, you could give it a number, but it was it was analog, it was waves. So, but anyway, I asked him, well, what do you do at HP? And he was working on a project to record video onto disk drives. And at the time, you know, we didn't actually have personal computers quite yet, but I'd heard about them, and you know, you could write Word documents, although it was long before Microsoft Word. You could write word processing documents with WordStar or somebody, and disks were fast enough to take those paragraphs and write that ASCII character set off to a disk and whatnot. And here this guy was going to record 30 pictures a second onto a disk drive, and I was completely fascinated, and I realized that started what's become a 40-year career of dealing with recording video onto disks. 30 years ago, I was with a company. We were building the first video workstation, and we needed a box that could record video a disc recorder, we called them at the time. And I worked with an OEM manufacturer down in Los Angeles, or kind of halfway between Los Angeles and San Diego, and they were making something for the space industry, and they could make us a disc array that could record 100 seconds of video. And when I marketed it, it was the first digital disc recorder that could record 100 seconds of video. And that was a big deal because the only people that were doing lots and lots of layers of video were people like Charlex and these special effects houses that were doing portions of a 30-second commercial. So there was maybe 5 seconds of the commercial that was really complex. And if you had 100 seconds you could record, you could have a lot of layers that were 5 seconds long. So that was really great. And the way they got there was they took disk drives, and they opened them up. They got the 5 heads that were reading off of the disk drives, and they modified the electronics in there so all 5 heads could read off the disk all at the same time, instead of just one versus another versus another. And that way that disk drive then was effectively 5 times faster than it was when it came from the manufacturer. And by putting enough of those disk drives together, they had a system. I remember asking him, well, disk drives keep getting faster and faster, and they were starting to tie them together in these RAID sets. Do you envision a day when you'd be able to put a bunch of disk drives together and you'd have an array that was fast enough to record video? And to this day, he said to me, no, I don't think that's ever going to happen. I think the economics of it are such that we're always going to have to open up the disk drive, modify these heads, and read all 5. And looking back on it now, I don't know if he really believed that or if he was just trying to continue to sell me his OEM version of a disk drive. But he was a good guy, and we had a good relationship, so I didn't question him on that. We went on. 20 years ago, 100 seconds of, this is uncompressed standard definition, 270 megabits per second, mind you, right? So it was, I think it was pretty cheap. I think it was $25,000 or $30,000 for that 100 seconds. So that was a big deal. 20 years ago, I was at SGI. We sold the first terabyte of storage to a broadcaster for recording television broadcasts. Standard definition still, I think, at that time. Want to guess how much that 1 terabyte to KGO cost? 20 years ago, this is 1999. Wasn't that long ago. $800,000. $800,000. It was 4 racks. Of course, it came with a server. So the server was probably about $80,000 of it, and the rest was 3.5 6-foot racks of disk drives to get to a terabyte. 10 years ago, we launched something called Media Grid at Omnion, and I was very confident at the time to talk about, what am I going to the podium for? There's nothing there. Very confident at the time to talk about the ABCs of media storage. And by that, I meant application integration, right? I mean, in the early days, it was Avid, it was some other people. You had to have an editing application that was well integrated with the storage. If it wasn't, it didn't work. There weren't enough standards out there that were being followed that you could just take anybody's storage and put it with anybody's video editing application. So application integration was first. Bandwidth, you needed bandwidth. Heck, back here, you had to modify the disk drives to get to the bandwidth. Capacity, you needed capacity. So that's ABC. You needed capacity, and you needed capacity at a certain cost. And that really has been the issue, I would argue, well, maybe up until just a few years ago. I think that capacity thing started to diminish in terms of cost. I mean, every media company I've ever talked to up until a few years ago, they didn't have enough money to buy the capacity they really wanted. Well, now we're talking about disk drives that are so big that we're to the point now where capacity is not so important. And I'm going to talk about, so that's A, B's, and C's. I'm going to talk about D and E here in a minute. So let's go on to today. So today we've got systems that can play back or record dozens of the highest resolution video at one time. They can play back and record hundreds of broadcast quality HD video at a time. They can play back thousands, if not tens of thousands, of distribution quality video like you would get from a Comcast kind of environment, or an over-the-top streaming service where you have one, not even that large of a disk array system. It could play back 1,000, 2,000 streams. So we've come a long way, and we've solved ABC. I want to talk about media and entertainment for a minute, and media work use cases or workloads, or not even workflows, but just the workloads of the systems. And they vary quite a bit. They vary from, very common broadcast news and sports, typically 50 megabit a second type stuff for HD, what we might think of as relatively highly compressed, not as compressed as when you go to distribute the content, but pretty darn compressed, certainly compared to anything you might do in a video post-production house, where you could be working at anywhere from 220 megabits a second to well over a gigabit a second and beyond for, we talk about 4K, but we got a lot of houses that are working at 6K and occasionally 8K. And, you ask a post house like a Deluxe or any of these folks, well, what format of video do you work in? And the answer is all of them, because they're a post house. Whatever the client comes in with, that's the format we work with today. So it's not a matter of, oh, gee, we can lock that down. Broadcast studio can lock that down, right? They got the cameraman, they got the editing, they've got the distribution. They're going out through broadcast. They can say, this is the format we're going to work in, and we can buy all our equipment and have it work in that format, and everything is hunky-dory. Down here, you're doing work for hire. Could be any kind of format, any kind of resolution. And then there's other types of video or media workloads that are maybe you don't think of, that aren't quite as much about video editing. There's the work that goes on in animation, which is really a little bit more like computer graphics, a lot of polygons. There's certainly some need for playback and some need for real time in that kind of environment. But the big thing here is there's a need to render. And when these folks render, they're not taking bits and polygons off of the disk drives and sending them to a server to be rendered. They're pulling off those bits and polygons and serving them up to 10 to 100,000 cores in a server farm or a render farm at one time. So now we're back to performance. We're back to latency. How fast can they get those polygons out to all these different cores? Because they're not asking for the same polygons at the same instant in time. So here it's more about performance, a little bit less about throughput. And then you've got internet media services, which is typically all about capacity. Some of these folks, several of these companies here have over 10 billion photos on file from people. And you go, well, it's just a photo. It's not 30 frames a second. But you do the math, and 10 billion photos is a heck of a lot of frames. If you went to play those 30 photos a second, you'd be sitting there for years to see all those photos. And they store those photos in 3 different resolutions oftentimes. So it's a massive capacity problem. Sports, religion, and corporate. What happens on the weekends and what happens during the week. This is a lot like broadcast. Here's a corporate environment right here. We're cutting videos. We're doing it at kind of broadcast resolutions and maybe a little bit higher post resolutions, but typically not 4K occasionally. But we're putting programs out. We're transcoding them. We're making them available on YouTube and a variety of other streaming formats for our own people, for our customers and whatnot. So this looks a lot like a combination of a couple of other use cases. And then something that NetApp, this is more the core business of NetApp down here, that's not so much media workloads, but is specific to these kinds of businesses. How do they keep track of all that video they have? How do they keep track of all the eyeballs they have? How do they keep track of who's paying and who's not paying for things? How do they distribute that content out there? They may be complex topologies around getting the content out there. They may have a core data center, or maybe 2 data centers that are replicated, and then they may have a half a dozen or a dozen different edge operations where that video is playing in the neighborhoods or whatnot. And then we have an awful lot of people doing software development. A lot of this is software development down here where people are developing their applications that are running in that media world. So when people ask me if NetApp is in media, because if you were to look at any of the publications, NetApp is definitely not in the advertising, we're in media business, but we sell, what did that sign? It said 300 petabytes every 12 months in the media and entertainment. So it's a very different world now than it was even 5 years ago, let alone 10. Thank you for doing all that talk on SAN and NAS and everything. I don't have to go into that. Once you've gotten up to this level of seeing these things, so each of these platforms, if you will, have a specific use case that they're good at, okay? Certainly, like he says, SAN is still really great for guaranteed, putting environments together, not having to worry about what the Ethernet topology is to all of the workstations. But I guess where we might differ slightly is certainly scale out NAS and what's happening today with Ethernet and servers. He said, you know, the problem with NAS in the early days is all the video had to come out through the server, and that servers were too slow to move that video through the server. You had to have a SAN because you had to get the bits to the workstation fast enough, you had to have nothing in the way. Well, today we're working with people that have a lightweight server. It's not even that expensive between the storage and the edit stations, and that server can pump 19 gigabytes a second. Well, if you do the math, 19 gigabytes a second is plenty of video streams. And if you need more, you attach a second server. It's not that big a deal. So it's not about gigabit Ethernet here. It's not even about 10 gigabit. It's about 25, 40, 50, even 100 gigabit and multiple 100 gigabit interfaces. So, you know, if you go back 40 years ago, Ethernet wasn't fast enough to reliably control a videotape recorder. Today, you're pumping the highest resolution of video through Ethernet. So people talk about, you know, oh, gee, with the advancement in resolution and the 60 frame per second kind of stuff we're doing, you need more bandwidth out of these storage devices. Well, think about Ethernet going from, I mean, I remember when a megabit a second Ethernet was fast Ethernet. All right, now we got 100 gigabit, so 100,000 times faster than we could move bits over Ethernet 40 years ago. Video resolution has not increased 100,000 times in that period of time. I love showing this to engineers because I can't show it to non-engineers because it's a Venn diagram and it's too complicated for them. But we had this, when I got to NetApp 8 years ago or so, it was a one-product company, or it had been a one-product company for over 15 years, and they had just purchased E-Series from LSI Logic, and E-Series was a different platform, a different beast, a horse of a different color. They didn't, our sales force and resellers didn't know how to sell it. They didn't know who to sell it to. They didn't know why anyone would buy it. It didn't have all these enterprise features that are needed in data centers, in business, in banks and hospitals and all the businesses that we were selling to. So I was trying to explain to our sales force originally where this Venn diagram came from, and I worked with about a half a dozen system engineers in the company. I said, well, you know, they were like, well, no, ONTAP is better for everything. And the E-Series guys were saying, well, no, E-Series is really fast and cost effective. It's really good for some things. And we realized it wasn't an either or. You know, you can use any of these storage platforms or models to do just about anything. The issue is which ones are absolutely best at doing that, which ones are most efficient at doing that, because when it comes down to it, the customer has a finite amount of dollars and they don't want to overspend because they bought a platform that isn't really optimized for the kind of, let's say, performance and throughput and capacity profile and usage profile that they have, right? So that's where the Venn diagram came in. First it was ONTAP and E-Series. Then we added Storage Grid as a product, and Object Store, which is we'll get into in one of our slides here in a minute. And then we have an HCI product as well. And of course, we're doing an awful lot today with the cloud. You can buy NetApp ONTAP technology in something called ONTAP Volumes or ONTAP Volume Services on the AWS or the Google Cloud Platform or Azure, and run in the same fashion with the same monitoring tools, the same data reduction tools, the same data protection tools, the same data security tools, all the enterprise features that if you're a data center guy, you know and love from this world, you can run that in the cloud. So that's another option. I've made it yellow because it's kind of a technology in my mind as opposed to a platform. Cloud represents a lot of different platforms, but it's a certain deployment model, if you will. And over here, if you want lower latency, getting down in that sub-millisecond latency in anywhere from 10 to 100 microseconds, you can work with Flash. So this is kind of the core competencies. I've given you long enough to look at this. You guys have probably been reading this rather than listening to me. But the one thing you haven't noticed, I bet, is that now we've gone from ABC to ABCDE, okay? Data protection. I was talking to somebody earlier tonight. What's changed, you know, the minute you build something faster and cheaper and smaller, the bar gets raised and something else changes, and now you need something else. And the thing that you need now is it's no longer one E-Series box attached to one edit suite like Dave's early diagram, and he's editing away, and if his system goes down, well, it's not that big a deal. He can take a coffee break and somebody can get it up and running again, or they can reboot it. And if he loses the data, it's not that big a deal because they just shot the footage and they can re-ingest it into the digital disc recorder or into the array like we did in the old days. It's not that world anymore. Now you have these huge central storage systems. They're handling anywhere from a half a dozen to 50 to 150 different rooms. They're handling all the editing in a big operation. They've got the finished content there. They're distributing it to New York and Los Angeles and wherever they need to distribute it. And the whole enterprise, the whole media enterprise is running off of this environment. And it's no longer acceptable for that system to go down for an hour, ever. And not only that, it's running 24/7 because there's so many people accessing this, there's always something going on. So the usage pattern has changed, the need for resiliency has changed, and that's where data protection comes in, that's where enterprise features come in. So on the one hand, you need enterprise features like data reduction because you're paying more for your flash on a per terabyte basis, so you want to make the most use of that data reduction. You want data security because God forbid you don't want to have happen what happened to Sony and have your movie ripped off by North Korea before you release the movie. It's an issue. Didn't used to be an issue, right? You just had an array in a back room and it was connected to an edit suite and the internet was nowhere to be found in that room and it wasn't a problem. But today, these central environments, somewhere along the way, are connected to the internet. People can get into them. So there's enterprise features that are needed in these big operations that never used to be needed in media storage. And before you even get to that, data protection, right? If you've got this big environment, you don't want to be losing content. And if you get hacked and some ransomware gets into your storage and messing with your content or corrupting your data, you want to roll back to that point in time before that happened. When was that? How do you find that point in time before that ransomware got in there? Maybe the ransomware was put in there a week or a month before the attack actually happened. So you've got to go back and find when that hadn't been put in there yet and then bring that content forward. And all of that is about data protection. Data protection is about taking your data from your primary storage and making a copy of it, making a backup copy of it, making incremental snapshots so that you can do it in a very lightweight fashion and you can make a snapshot of hundreds of terabytes without everybody grinding to a halt while they're editing. So that's where the bar has raised. Never was an issue before. Wasn't an issue I want to say it wasn't an issue even 10 years ago in media storage. It's definitely an issue today. Same Venn diagram. I didn't want to hurt your eyes or your brains too much. But this is what those core competencies translate into when you go to use cases. You know, where are these things good? Again, you can use multiple platforms to do the same thing. It's just what combination of things are you trying to do, right? Transcoding is a lot about latency, that performance. How quickly can you grab a chunk of data and bring it up? How many IOPS do you have? I/O operations per second. Video playback is about throughput. It's about bandwidth. How much bandwidth can I get out of the system? Backups, maybe you use the cloud, public cloud. Maybe you use your own private cloud in an object store. If you're doing a lot of different things at once, you may want to have an HCI system that's becoming much more acceptable. It's not the most cost-effective for editing. It's not even the most cost-effective for transcoding, but it scales terrifically. It's easy to operate. And one of the points that Dave was trying to make about Ethernet, it's ubiquitous, so it's cheap. It's also ubiquitous, so there's a lot of people out there that know Ethernet and know how to hook it up. It's getting to the point now where if you have a SAN operation, nobody wants to like move to SAN today, because who are they going to have to run it? Who are they going to have to deal with fiber channel? They can't find anybody anymore to deal with fiber channel. Any engineer out there that's versed in fiber channels already got a job. So it's very difficult. Ethernet, anybody can do it. We lost a deal the other day to somebody because they bought a competitor's system. This isn't in media. They bought a competitor's system because they thought it was so simple they could train the receptionist to manage the storage. So that's a whole nother level of issue. So I'm just not going to take up much more of your time. I'm just going to run through a couple of examples and just kind of show you how varied the use cases can be, and therefore what platform we threw at. This happens to be a project Dave Van Hoy did, ASG did a while back. Very typical, similar to the environment here in many ways. In this case, it was, these are Adobe editors, aren't they? Or are they Final Cut Pro? I've forgotten. Does it say? Final Cut Pro. They're Adobe now, so I need to change this. It was Final Cut Pro when we did it. It was 3 sites. I think it was over here in Sunnyvale, their headquarters, and then LA and New York. It was a number of edit stations. Very, very common kind of an environment. They were cutting news together, but rather than broadcasting that news, they were putting it out on Yahoo, so they were then having to transcode it and put it out as a stream. They had, I've got to get with you and upgrade this slide. This slide's been sitting here forever, okay? They've probably even put in new storage since this point, huh? 2612, that's not that old. Way old. All right, fair enough. Very typical environment. So this was done with E-Series with Quantum Store Next on top. Okay, we might do it with Quantum Store Next on top today if we were to redo it. We've got a couple of other options we might do this deal with. Here's an interesting one. We've got maybe a dozen like this around the world. We all know CBS. They got tons of content. They're busy producing content. This install has nothing to do with editing the news. Nothing to do with editing the news, nothing to do with editing programs. This is all about the content they own, whether it was news that was cut yesterday or a television show they aired 40 years ago, and they have licensees all over the world that want access to that content, probably 500 different licensees around the world that they have contracts with. They are constantly transcoding that content, standard converting that content for Europe, making it available in whatever format that target destination, that licensee wants it in. They've got a lot of content they have to look through, so they've got MAMs for doing that. They've got a huge tape library to this day that needs to be accessed. So it becomes a rather involved system, and this has been an ONTAP system now for over 10 years. I just got this slide updated this afternoon. I've probably updated the NetApp products 4 times in the use of this slide because I've been using this slide for about 6 years. Most of the apps haven't changed over that period of time, but I bet there are probably a couple of new ones that aren't in here. So this is a whole side of an operation that we don't think about when we think about a broadcaster. They're a broadcaster, yes, but they're a content provider as well. Question? This LTO is being accessed constantly, certainly on a daily, if not an hourly basis, to pull content forward and then transcode it. So once it's been pulled forward, it's going to get transcoded and it's going to sit in the FAS, the NetApp FAS systems at that point, and then be put back on tape. But it's, yeah, I wouldn't call it cold storage. I think of this as an active archive, right? It's an active archive. It's got one tier within that archive that's relatively slow in terms of retrieval, but not that slow. I imagine that the drives in here are busy all day long, pulling content up and putting content back. It's just not pulling frames up and transcoding to them and putting them back. It's bringing chunks of programs forward. Good question. And then object storage, which is been a $0 billion industry for almost a decade, is starting to become something. This is an environment where we put our object store, we call it storage grid, in place. I need to update this slide now. It's over 35 petabytes of raw content. This is a German broadcaster, kind of is like a combination of a CBS and a DirecTV, if you will. They've got a business where they're making programs, they've got channels they're putting on the air, they've got streaming channels they're doing as well, direct to home around Germany. So it's kind of a combination operation. Think of them as a broadcaster / content provider. And now they've moved everything off of tape because those tape drives, again, were running back and forth all the time, content coming forward and going back. And it turns out tape is cheap. And robots add a little bit of cost, but the data management, the archive management software is on a per terabyte basis, so that adds to the cost. Tapes having to be replenished, tape drives failing, the amount of time it takes to pull content forward. You add all that together in a TCO, and it starts to look like, gee, why don't we just spend a little bit more money, we'll put everything on disk drives, it'll all be replicated and be resilient, we won't have to worry about the maintenance of dealing with a tape robot. So there's a certain point where people are cutting over off of tape. And that's kind of how it is. But so when these guys started, I think they started with, I don't know, 3, 4, 1, I think they started at about 1 petabyte. All right, but then they got that going, they got it working. They realized, gee, S3 is kind of nice. It's a lot like what AWS is doing. We can put other things on here, so we're just going to take all of our instances from our DevOps environment and we'll back them up. It's a cheap, huge pool, basically cloud storage in our building. Doesn't cost us anything for egress. We'll just put all our backups there too. And then DevOps folks can be writing to it and reading from it. And the media guys can be using it. We can move everything off of tape and put everything there. So it's become one big pool that's their own cloud, if you will. And it's replicated in 2 sites, so they're not going to lose their data. Yeah? Replication is not backup, except, well, we can go deeper on storage grid. This thing is incredibly resilient. It makes multiple copies. It's got multiple copies in multiple sites, and yeah. But you're right, it's not backup, and backup isn't what they want. They told us when they started down this path 3 years ago that we're going to have 2 sites of storage grid, and we expect one day we're probably going to back it up to a 3rd site in the cloud. Well, that would be backup to a third site in the cloud. I'm not sure why it wouldn't be backup.
I've done replication, and it's amazing how quickly replication works. And it's amazing how quickly replication can destroy your data.
Fair enough. Let's take that offline. That's a longer discussion.
The other comment I'd like to make is object storage has been used in the web environment for about 8 years.
Yep.
Used very extensively.
Yep.
It's well-known technology. And SMPTE 2110, one of the important features of 2110 is that it allows you to migrate to an object store very easily.
Oh, good. That's good to know. Yeah, we started with the CDMI interface, which was a consortium of people that wanted to have an interface, but CDMI never took off. Amazon has been very good to object storage in that it forced on the world, not just the industry, but the world, the S3 interface, and Amazon's made that available to all of us. So we cut over from CDMI to S3 about, I don't know, 3 years ago, 4 years ago, 5 years ago, that long ago? Yeah. And Storage Grid goes back. There was a company called Bycast that we purchased about 8 years ago, and Bycast was around, maybe started about 12 years ago. So this Storage Grid is about a 12-year-old system at this point. We rewrote much of it about 6 years ago, and that's when we started in on the S3 interface then. So we've been doing this for quite a while. And it's absolutely true that cloud storage has woken people up to the use of S3. Without that, S3 would probably still be sitting around with nobody wanting to use it. So it has been the web or the public clouds that have really pushed this interface and this way of dealing with storage. But it allows us to go from a million files or tens of millions of files to billions of files. So it gives us that headroom for these enormous libraries. And this library isn't going to ever probably make it to 1 billion files, but because the files themselves are rather large media files, but there are other uses of object store where getting to 1 billion files today is not that big a number. And I'm done. So, thank you. Yeah. So we'll do a tour of Building 2 if people want to go do it. I know it's late, right? You want to go do it? You've got a big smile on your face and you want to show it off? All right, Building 2 is, I would characterize it as NetApp's media operation or corporate video operation. There's a green screen room over there. There's a bit of a studio. There's a control room specifically for that. There's fiber and optics running underneath the campus between various buildings. So there's a few places that they can do recording and have that record straight back to this Building 2 for ingest into the shared storage system, which happens to be an E-Series system, and there's a media asset management system and a variety of Adobe editors and all of that good stuff. Every product that NetApp makes is prominently displayed. Odd that that would happen. I would take us over there. How many people would want to stay and do that? My gosh. Okay, off we go to Building 2.
Thank you.
Yep.
So just before we wrap up, thank you very much to NetApp for hosting us. Thank you very much to the crew next door for doing the video stream.